Draw all the three views of a point capital P lying 60 mm below HP, 70 mm in front of VP and 40 mm from RPP. Also state the quadrant in which it lies. So here it says below HP and in front of VP. If you are considering below HP and in front of VP, below HP, in front of VP. So below HP means on vertical plane, in front of VP is on the horizontal plane. Obviously, so this will be 0 origin. So you are moving it in this direction, that is 0 degree with respect to this, and with respect to this it will be 270. So 270 to 0 means it will be the fourth quadrant. So the condition is 60 mm below HP, 70 mm in front of VP and 40 mm from RPP. Also state the quadrant in which it lies. So here, if I want to see the image in the vertical plane, then I have to look from the front view. So the front view will be perpendicular to the vertical plane. So image which can be seen will be in the VP. So when you look from the top view, we can see the image on the horizontal plane because the top view is perpendicular to the horizontal plane. If I want to see the image in the right profile plane, we have to look either from the left side view or it can be from the right side view. Whether we look from the left side view or from the right side view, the image will going to fall on the right profile plane at this point. So because both the side views will going to be perpendicular to the profile plane. So now from which direction we should be able to look. So for that, the condition of observer will going to play a major role. That means when I look from the front view, the object is between the plane and the observer. If you look from the top view, plane is between the object and the observer. And if you look from the left side view, object is between the plane and the observer. And if you look from the right side view, plane is between the object and the observer. So always to decide about the image in the right profile plane, we have to look, condition for this has to be, the front view condition has to be satisfied. That means when the observer is looking from the front view, so object is between the plane and the observer, the same condition has to be satisfied. That is possible only when you look from the left side view, object is between plane and the observer. Why we should consider only the condition of the front view? That is basically because always the vertical plane will be aligned with the right profile plane. So that is what we can see here. The vertical plane and horizontal RPP will going to be aligned. This is the intermediate position of the rotation what we have shown. So that means I can look from the left side view in the fourth quadrant. So the condition will going to change now. That is point P lying 60 mm below HP, 70 mm in front of VP and 40 mm in front of RPP. In front of RPP means it will be the left side view. So when you look from the front view, we can see the distance below HP. So that distance is visible in the vertical plane. Then when you look from the top view, we can see the distance in front of VP. So that in front of VP distance is 70 mm. That will be visible only in the top view, that is here 70 mm. And when you look from the side view, we can see the distance below HP and we can also see the distance behind, in front of VP. Both will be visible. That means if you look from the left side view, I can see the distance below HP means it is the front view distance, and I can also see the distance which is in front of VP, that is the top view distance. Now we need to, but when you look from the front view, we can also see the distance in front of RPP, which is seen in vertical plane. If you look from the top view, the in front of RPP distance can also be seen in the horizontal plane. So the distance with respect to the profile plane can be seen in vertical plane and as well as in the horizontal plane. And always both P dash and P double dash will going to lie on the same line. So here, this is the three-dimensional analysis what we have considered. So in this step 2, here we are cutting along this and rotating horizontal plane downwards, right profile plane in the anti-clockwise direction, so that both VP and RPP will be on the same line, and HP and VP will be overlapping, which is below the XY line. So now we will go for the next one. So this is after rotating the planes by 90 degrees, and correspondingly the images also will be rotated by the same angle. That means both VP and HP will be aligning with below XY line and RPP towards the right side. And then the distance with respect to the profile plane is seen in both VP and HP. So since VP and HP is below XY line, you can see the distance of 40 mm with respect to this line, which can be seen here. So that will draw a vertical projector here. Then the distance below HP is the front view. That is, below HP distance will be seen in the vertical plane. Since the image is on vertical plane, it is P dash. And then the distance in front of VP is seen in the horizontal plane. The horizontal plane is also below XY line. So from here, you measure the distance of 70 mm. And so here, when you want to write the profile view, so in the profile view, both the front view distance and the top view distance can be seen. So when you project this P dash, so into the profile view, so therein the below HP distance of 60 mm, it can be seen in the front view and as well as in the side view. Now the distance with respect to the top view, that is the distance in front of VP, which is 70 mm here, is vertical. When it is projected till here, this 70 mm will go to come here. So that means 70 mm will be behind VP, I mean in front of VP is here. So then we need to draw an angle at 45 degrees. When you draw an angle of 45 degrees with respect to the vertical, then this vertical distance of 70 mm is transferred into horizontal distance. That means below HP is here and in front of VP is here, but both will be on the same line. So that means where you have the front view, on that line you are going to get the side view. So then you project this till here, so that P double dash will going to be on the same line as that of P dash. So this is how you will be able to analyze this fourth quadrant problem. Now we are going to try to draw the solution in the sketchbook. First we are going to draw the XY line and the X1 Y1 line with the thin lines, and mark XY and X1 Y1, and mark VP and HP is the one which is rotated. So your keep it in bracket, and RPP towards the adjacent to vertical plane. All should be written below XY line. Then first condition is we should be able to consider the distance in front of RPP. So the distance in front of RPP can be seen in both horizontal plane and also in the vertical plane. So from X1 Y1 line, you measure the distance of 40 mm and draw a vertical thin projector here. Then the distance below HP can be seen in VP. So VP is below XY line. From this point, you measure a distance of 60 mm and you mark this point, which will going to be P dash. Then the distance in front of VP can be seen in the horizontal plane. So from here, you measure the distance of 70 mm and mark it on this. So you're going to get this point, small p. So this is 70 mm. Then you draw a horizontal projector from P dash to the profile view, and then draw a horizontal projector from P to also to the profile view. Since we need to project the top view point onto the profile view, first we are going to draw a 45 degree line with respect to the XY by using the protractor. Then draw a line. Then draw a horizontal projector from P to the 45 degree line, so that the vertical distance of in front of VP 70 mm is transferred into horizontal distance, and where the front view is there, on that line you will going to get the side view. Then project from this point upwards, so that it will going to intersect at this point. You make the write it as P double dash. So this will going to be the side view, and then mark P dash, P and P double dash. Then give the dimensions 40, 60 and 70, and then he says also check the quadrant in which it lies. The point capital P lies in fourth quadrant. So this is the final solution what it has to be written in the